Okay, so a very big part of algebra and in mathematics in general is knowing how to graph various equations and functions. And what I have for you here is a nice, easy example that every single person trying to learn algebra should find pretty easy to graph. So the question is y equals x squared minus 4. Can you come up with a quick basic sketch? Now, for those of you that know how to do this, it'll take you all of about maybe 15 seconds to actually come up with a sketch. You don't have to have the most perfect graph in the world. Of course, you want to be as accurate as possible. Now, you can't put your graph into the comment sections, although I wish you could. But what you could do, if you know how to do this problem, is just kind of generally describe the shape of the graph and maybe some key points that are on that graph. Now, of course, I'll show you the right answer to this in just 1 second, and I'm going to fully explain this. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades, and it really is my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go and take a look at the actual graph here. Again, we're talking about a sketch, nothing perfect, but let's go ahead and take a look at the answer. And you should have come up with something like this. So what we have here is a shape. This U-shaped thing here is called a parabola. And the key points here are going to be 4 on the y axis right here. Okay, so that would be one key point. And then here, the graph, this parabola is crossing through or intersecting the x-axis at -2 and 2. So those would be some key points. Of course, you could have others, and this graph can be even more detailed. This particular location right here is actually called the vertex, but I'm just going to make this a quick kind of introductory level video on how to graph a parabola, because they certainly get much more complicated than this. And hopefully you found this easy. And if you were able to identify this graph as the graph that you're actually that you actually knew how to do, well, let's go ahead and celebrate by giving you a nice little happy face, an A plus, a 100%, and multiple stars. So you can brag to your friends and family that indeed you are a certified professional expert in graphing quadratic equations and parabolas. They'll be like, I have no idea what that means, but it sounds pretty cool. All right, so for those of you that are maybe concerned that, oh, I'm trying to learn algebra and, I don't even know what's going on here. Well, it is possible that you have not yet studied this. Okay, so that is a possibility. And what we're really talking about here is graphing quadratic equations. And quadratic equations are a huge part of algebra. And I'm going to show you how easy it is to graph parabolas or certain type of parabolas. This, again, it gets far more complicated than what I'm going to be covering here. But oftentimes the problems you do in algebra are pretty easy, like this one here. Let's go ahead and get started now. So again, what we're dealing with here, and here's our problem, is a quadratic equation, okay? And here this is y equals x squared minus 4. This makes this a quadratic equation because what we have is an x squared, okay? This is what we call a second degree polynomial, and even if you don't know what that means, basically this is a one variable to the power of 2. And this is an equation. Now, sometimes we can write this equation by itself, like x squared minus 4 is equal to 0. That is a quadratic equation because we would want to try to solve for x. Or we could even write this particular equation instead of this y here. We could have f of x, because f of x is the same thing as y, and we could kind of classify this as a quadratic function. But here, this y, because y and f of x is the same thing, somebody might be a little bit lost. Don't let the notation overly confuse you. We are dealing with a quadratic equation, so y is going to be equal to this quadratic equation. Now, the main thing about quadratic equations is the shape of them is a parabola. Okay, and there's other things you want to be thinking about when you're see a quadratic equation in algebra. You need to put on your quadratic equation thinking cap. Let's review some of these kind of main ideas that all of you out there that are studying algebra, and if you see a quadratic equation, you should be thinking in your brain, okay, what's going on here? Well, when you want to solve a quadratic equation, it's possible you could take the square root of both sides. Now, not in all situations can you do this, but some you can. You can also factor sometimes to solve a quadratic equation. Now, if you can't take the square root of both sides or factor to solve a quadratic equation, you can always use the quadratic formula to solve any and all quadratic equations. Now, there's another technique that's really not as practical, but you need to know it's called completing the square. So these are just different methods to solve a quadratic equation, and all quadratic equations will have two solutions, okay? Now those could be two real number solutions or two imaginary number solutions. I'm going to show you how the solutions are linked to a particular type of graphs here in a second. But right down here I have parabola, okay? So all quadratic equations, the graphs of quadratic equations are parabolas, okay? A parabola, which is a U-shaped graph, and we're going to talk a little bit about different types of parabolas on the XY axis, things that you should kind of be very, very kind of familiar with. Some, again, kind of introductory level stuff about graphing quadratic equations. Okay, now before I get into all this good stuff, I would definitely love it if you got into just hitting that subscribe button, hitting that notification bell. This has a tremendous positive impact on the growth of my YouTube channel, and it really would mean a lot to me. And basically, it's the thing, seeing my channel grow, really just keeps, adding the more motivation, because I'm already motivated already just to try to continue to teach as much as possible. I'm obsessed with helping all of you out there learn math, and if you like my teaching style, this really does help. So let's get back to the video. Now, I did talk about parabolas. Now, a parabola is a U-shaped kind of graph. Now, I'm just sketching a parabola here, and here we have the x, y coordinate plane, and these are some examples of parabolas. Now, I'm going to kind of get into some main ideas about the graphs of parabolas. So you can have a parabola that's like a one that goes in this way, or one that goes upside down. Now, when you have a quadratic equation, and the coefficient, the sign in front of the x squared part right here is positive. Okay, you have a positive number. For example, if I had y equals 2, or let's do something a little bit more interesting, like 5x squared, something like this. This is a positive value. You're going to have a positive, or what I call a happy parabola. Just kind of think of this was like a little happy face. This is a happy parabola. It's smiling. So quadratic equations with positive coefficients are going to have graphs that look like this. Now over here we have a sad parabola. So you might be guessing, well, does that mean that it has a negative coefficient? Yes, indeed. So something like maybe y equals negative 7x squared. So if the coefficient's negative, you're going to have a upside down parabola. Okay, so real kind of basic concepts. And a few other things too about these parabolas, the graphs of quadratic equations. If I increase, let's just take y equals x squared. If I make the coefficient a large number, the graph becomes skinnier. So in other words, if I had y equals 15x squared, that parabola is going to be positive, happy, and it's going to be very, very kind of skinny like so. Okay, now if I open up or lower that coefficient, like y equals 1/4 x squared, it's going to become wider like so. Okay, all right, so just again, main ideas. Now there's another very, very important thing that I'm going to be highlighting in this particular graph. We're going to look at some more examples because I just want you to get the general kind of idea behind equations and the graph of parabolas. Now notice here in our parabolas, they intersect the x-axis, okay, right here and right here. For this particular parabola, these x-intercepts, okay, right here and here, are the real number solutions, okay? So whatever the equation was to this particular parabola, if I wanted to solve it, I would set it equal to 0, and I would find the real number solutions, okay? Remember, quadratic equations have two solutions, as I kind of indicated in my little summary chart there. and these are the actual locations of them. It's always the x-intercept for real number solutions. And I'm going to talk about another situation here in a second. So if I have a sad parabola right here, in this particular case, would be our two real number solutions. Okay, so let's take a look at some other situations that definitely can occur when you have parabolas or quadratic equations. So let's take a look at this one here. So here is our parabola. It's a happy parabola. So in other words, its graph might be something like y equals 5x squared. It's positive coefficient. But notice here, it's not crossing through the x-axis. Okay, so in other words, this is doing this. Its vertex, which is the maximum or minimum, is right here. Okay, it's above the x-axis. So where are the real number solutions? In other words, it's not crossing through right here to have our two real number solutions. Well, in this case right here, when your parabola does not cross the x-axis, these would be two imaginary number or complex solutions. Okay, and I'm not going to get into that now, but again, all quadratic equations will have two solutions. Sometimes they'll be imaginary and sometimes they'll be real, like in this case right here. Okay, so if you do have imaginary numbers or complex solutions, your graph and your polynomials in general will not be crossing through the x-axis. And what I'm talking about here is kind of also transcends beyond quadratic equations, and really we're talking about polynomial equations in general. Okay, so this concept of graphs that cross through the x-axis, the points, those intercepts, x-intercepts, are actual real number solutions. Now, there's another point here for graphs that we want to take note, and that's this point right here. That's the y-intercept. Okay, it's the point where the graph crosses the y-axis. So if I wanted to, for example, find the x-intercepts, I would take, let's just kind of make something up here. If I have 5x squared plus 7, something like so, I would take this equation and set it equal to 0. 5x squared plus 7, set that equal to 0. Doing this is basically, if I could solve this equation, I'm finding real number solutions, or I'm looking for the solutions. Now, if they turn out to be imaginary number solutions, then you know that this graph is something like this. Okay, so when you want to find the x-intercepts or solve this, you're going to set y equal to 0. Okay, now when you want to solve for the y-intercept, you set x equal to 0. Okay, so you can see here, right here, we're getting closer and closer to 0 on the x-axis. So that's the location for the y-intercept. So I would basically plug in 0 for x, and whatever was left is going to be the y-intercept. Okay, so if you're a little bit overwhelmed here and you are studying algebra, you're definitely just going to need to kind of get some more instruction and practice the basics. Let me give you a few recommendations before we actually continue on with the problem. Check out like my Algebra 1 course or Algebra 2 course. You'll find links to those in the description of this video. Also, I have a ton of additional videos on my YouTube channel on this topic as well. Okay, so again, what I'm trying to do here in this video is not just teach you how to graph this one specific problem. I want to give you a good overview, a good feel for quadratic equations and parabolas. So you can, for when you get into more complex problems, you just have some good situational awareness. And hopefully what you're seeing so far is not too overwhelming. Okay, so let's go ahead and take a look at one other scenario, and then we'll actually do this problem. So what happens if we have a graph and it kind of bounces off the x-axis? Well, we talked about situations where things are crossing through and chopping through at 2 points like this, right? So those scenarios would be basically real number solutions, like right here, right? So that's a real number solution, that's a real number solution. So here, this one is kind of bouncing off the x-axis. We're like, well, where are our two solutions? It only looks like we have one point of intercept. It's actually it's just bouncing at one specific point. Well, in this particular scenario, this is what we call a double root, okay, a double solution. So a double root is basically you have two solutions, but it's the same number. So like, for example, x is equal to 3 and x is equal to 3. Again, there's always going to be two solutions to a quadratic equation, and if you have a double root, which is, you certainly can, its graph will be bouncing in some way off the x-axis. Okay, so that's a good, quick general overview of parabolas and quadratic equations. Let's go ahead and get to this actual problem here. So again, the idea here is to come up with a quick sketch. So we have y equals x squared minus 4. And the best way to kind of think about this problem is you want to get the basic shape of a quadratic equation graph. The most basic parabola or quadratic equation you could be asked to graph is simply y is equal to x squared. So I said, hey, graph y equals equal to x squared. Let's start with that, and then we're going to basically take that graph and translate it or move it. We're going to do something to that particular graph, and you'll see it's very, very easy. But this is kind of another thing about graphing in algebra, graphing functions. You need to understand the basic shape, and then you need to understand how to translate that shape. Okay, and again, we're talking about critical algebra skills that all of you need to know if you're at this level of mathematics. So let's go and talk about the basic shape of y equals x squared. So y equals x squared is the most standard basic parabola you could have. And this is a sketch, it's not perfect. So here's a parabola, it's happy, right? Because we have a positive x squared. It's bouncing off the origin, okay? So there's a double root, 0, 0. And there's symmetry, okay? In other words, this side is symmetric to this side, so mirror image. So here is our nice, lovely, basic parabola. Okay, now what we can do is translate this. In other words, I can move this graph any way I want. I could move this y equals x squared, or this x squared parabola down. I can move it up. I can move it left. I can move it right. I can kind of shift this vertex. And when you get into graphing more interesting quadratic equations, you're going to have to find that vertex point and then kind of reconstruct the graph. But this particular problem, as I indicated with the title of this video, is a very, very easy problem to do indeed. So now that we understand the basic shape of y equals x squared, y equals x squared minus 4 is our graph, and it's all we're doing, this minus 4 part here just translates it down the y-axis, the vertex down to 4. Okay, it's actually negative 4 right here, but it's 4 units down. So this would be y equals x squared minus 4 right here. Okay, or we have our parabola, and we're going to just keep that same shape and move it down to negative 4, or 4 units down on the y-axis. So this would be actually negative 4. Let me make that correction there. So this is basically what our parabola is going to look like. Okay, so you could just say, okay, I have y equals x squared minus 4. You could just kind of sketch a parabola that's symmetric, and it kind of goes through its vertex, its minimum right here. That's what we'd call that, or the vertex where it's doing its little U-turn is at negative 4. But we would really want to make our graph a little bit more interesting. And this also is the y-intercept. So in this case, you can see that this parabola is crossing through, or will cross through, the x-axis. So these are the solutions to this particular equation. And these x-intercepts are also known as zeros. You'll hear the word roots or solutions. So zeros, roots, solutions, x-intercepts, we're all referring to these points here. So to really kind of spruce up this graph and give it a little bit more detail, we can find these zeros or x-intercepts or the solutions quite easily by just solving x squared minus 4, setting that equal to 0. So let's go and do that right now. Okay, so again, to find, I'm going to make that correction right there. So to find these points, all we need to do is take this right here and set it equal to 0. And when we solve that, we'll find these x-intercepts if, in fact, this equation has real number solutions. If it does not, it's going to have a imaginary number solutions. But we already know, because we know the basic shape, that this thing has to have real number solutions, because the graph will chop through or intersect the x-axis. So that's the thing what I'm kind of really trying to get you to connect, is that, hey, once you have an idea of the graph, the type of equation, and all these other things, you should be kind of pulling, kind of connecting the dots so you can anticipate the type of answer you're looking for. So let's go ahead and solve this basic equation right now. So we have x squared minus 4 is equal to 0. Super easy. I'm going to move that 4 to the other side. So I have x squared is equal to 4. Take the square root of both sides. You have x is equal to positive negative 2. These are the locations of my x-intercepts. These are my roots or zeros or actual solutions to this quadratic equation. So this would be our final product or quick sketch. And this would be, pretty much what I would be looking for if I was your math teacher. If you put negative 2, 2, oh, I got to put a negative 4 in there and have my little parabola, and you're showing, it doesn't have to be perfect again, but you're showing, you're showing that you understand that this is a U shape and it's pretty much symmetric. Again, when you're graphing, you're not going to make a perfect graph, and you shouldn't spend too much time trying to make your graph as accurate as possible, but you do need to kind of, show that you understand the general shape and general characteristics of that graph. And you absolutely are going to need to know how to solve solve quadratic equations and graph quadratic equations and all different sorts of parabolas. This is an essential algebra skill. But anyways, if you understood all of this, that is fantastic. Again, if you don't, it's probably, just indicates that one, you may not have yet started to study quadratic equations, but I guarantee you, you'll be studying them very soon, especially if you're in some sort of algebra course. Okay, so with all that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.